Welcome to Creative World. In this video, we will solve Chapter 2 exercise problem number 2.23. While solving this problem, we will be using Kirchoff's voltage law. This law states that sum of supplied and dropped voltage across circuit elements in a closed loop is always equal to 0. According to this law, cumulative voltage across circuit elements in a closed loop is always 0. Now move towards the problem. Exercise problem number 2.23. Find voltage VBD in given below figure. This is the circuit diagram of given problem. We have to find the voltage across these 2 points B and D labeled as VBD. Label VBD is indicating that B point inside the circuit will be on higher potential than D point. If we observe, the information that is provided in this circuit is in the form of voltage. No other circuit element parameter is specified. So we will use Kirchoff's voltage law to solve this problem that is purely based on voltage. And before we start solving this problem, first we have to identify the direction of current inside this circuit. We will assume the direction of current inside this circuit is clockwise. Now we are interested to calculate the voltage across these two terminals B and D, and B is on higher potential than D. Voltage between these terminals is labeled as VBD. Now we can apply Kirchoff's voltage law inside this closed loop to calculate the value of voltage VBD. We will start from this voltage source. Current entering terminal is negative, so the voltage across this voltage source will be taken with minus sign. Move to the next element. Current entering terminal is positive, so voltage across this resistive element will be taken with positive sign. Move to the next point. Current entering terminal is positive. This voltage VBD will be taken with positive sign. So the KVL equation for this part of circuit is minus 12 volt plus 4 volt plus VBD is equal to 0. In this equation, we only have one variable, that is VBD, and we are interested to calculate its value. So solve this equation. Place this minus 12 volt and 4 volt value on the other hand side of equal to calculate the value of VBD. This minus 12 will become positive 12 and plus 4 will become negative 4. Now subtract 4 from 12, the answer will be 8 volt. So the value of VBD is 8 volt. This was exercise problem number 2.23. Thank you. See you again in next video.